All right, let's talk about deleting from the list. So there are three possibilities, just like there were for adding to the list. We can delete a node at the beginning or the head. We can delete a node at the end or the tail, or we can delete a node somewhere in the middle. So let's talk about deleting from the head. So we are going to okay, let me backtrack. To delete a node from the head, we are going to set the head reference to the next node, the node that the node at head points to. That's kind of confusing the way I wrote that. I apologize. And that's all we have to do. Why? Because the current head, the head reference was the only thing pointing to the previous head node, right? That's why we have a head reference, is because otherwise there's nothing referring to it, and the garbage collector is going to come and destroy it. So that's why we have the head pointer in the first place. So if we just move the head pointer to whatever that node is referencing, just move it one spot down the linked list, then all of a sudden the previous node head is floating off into nothing and it's going to get destroyed. So that's kind of a handy use of the Java garbage collector. You can't necessarily do this in other languages like C++, where you have to delete your own memory. But we don't need to worry about that right now because this presentation is about Java. And then once we've done that, we decrease the count. So this text-heavy slide might be a little confusing. It's going to be a lot less confusing when you look at this. So deleting head, we are going to set the head pointer to head.next. So the head pointer just moves over one spot in the array. Or sorry, not the array, the linked list. So now the previous head, it's gone. The garbage collector came and collected it. So now our new head is the one that we just made the head reference refer to. And we're all fine and dandy. So then we're just going to check to see if the count is not equal to 0. So if there was anything, in the list to begin with, or if, there is something left after we've deleted that head. Maybe the head was the only thing in the list. Who knows? If the count is, greater than 0, still we're going to take the count down to 0, or take the count down one count minus, so that because we just deleted a node. All right, let's talk about deleting from the tail. So, like deleting from the head, we need to move the tail reference to the previous node, right? Because if we move the head reference to the next node and let the head reference, let the previous head node just get deleted on its own, well, wouldn't it make sense to just move the tail to the previous node to the tail and just let the tail be deleted? And yes, that's what we're going to do. However, we don't know what that previous node is. Because all of our nodes point to next, they all know what is next in the list, but none of them know what comes just before them in the list. So we have to find this kind of manually. And we're going to do a similar thing that we did to find the index in that adding method, where we're going to take our temp node. We just need one right now. We don't need the previous. And we're going to set it equal to head, and we're going to use a while loop to advance it until temp.next is equal to the tail. And that's how we're going to know that temp is now the node that's previous to the tail. Or the second to last node is another way to think about it. So we're going to reassign the tail reference to the node that temp is referring to. And then we're just going to set tail.next equal to null, right? Because we've moved the tail reference. We're going to set tail.next equal to null. Now the previous tail has nothing pointing to it, and the garbage collector is going to come destroy it. So this is what that looks like. We got our public void deleted tail. We create a new node reference and called temp, assign it to head, so it's pointing to that same node at the start of the list. And we're going to say while temp.next is not the tail node, right? Because if it were the tail node, we'd know that temp is the node before that, because that's what it's referring to as the next node. So we're just going to say temp equals temp.next to advance that temp one place down the list. So once we found this, once the loop exits, we know that temp is the previous node to tail, right? So then we can just assign tail to temp to make temp the new tail, right? And then since temp is pointing to tail, it still has tail still has a reference, so it's not deleted quite yet. We have to set tail.next or temp.next, either way, equal to null. And then we'll completely sever that node from our linked list, and it will just be deleted. And then again, if the count is greater than 0, take the count down.